Okay, so moving on from there, those are our threats to internal validity that can come within subjects experiments, all related to time in a way. Now, a couple more though, are participant mortality, as well as some other couple other ones we'll get to in a second. So, participant mortality is when people drop out of your study, but it's more than that. When people drop out of your study at random, it's known as attrition. Because people lose interest in the study or they don't want to do it anymore and they quit. This, of course, happens all the time because ethically we're not allowed to force people to finish the study if they don't want to. They have the right to withdraw at any time. However, so in a lot of situations, this isn't going to be a big problem. Sometimes in a particular study, you don't really know. People just kind of drop out at random. They drop out in some sort of non-systematic way. However, that's attrition. When we talk about mortality, it's actually selective, and people drop out based on some condition or some factor that's actually going to affect the internal validity of your study. Okay. So here's some examples of that. Let's say you're running a study on weightlifting, and you have pretty people try a couple different programs, a couple different weightlifting programs to see which makes them the strongest. Well, and you find that some people are dropping study. Could be the case that people are dropping out at random, so they're just don't want to do the study anymore and they give up. However, think about it for a second. Might there be some people who are more likely to drop out than others? Think about that for a second. Well, that certainly could be the case. How about people who are not making good progress? So let's say someone signs up to do a weightlifting study because they want to learn more about weightlifting, or they want to try whatever it is you're recommending. Um, it certainly seems plausible that people who quit might be non-representative of everybody. Maybe they quit because the program is not working for them, whichever one they tried. If that's the case, that could really threaten the validity of your study because now you're left with a sample that is just people who the program was working for, or rather, mostly people that the program was working for. That's not really a fair, you know, a fair takeaway, right? If you publish this study and you say, look, almost everyone who did this particular program showed showed progress. Well, maybe that's mainly because the people who it wasn't working for decided to quit the program. Another example would be depression treatment. So if you're testing, let's say, some new experimental medication for depression, and you're trying this on people, I mean, who's most likely to quit if it's not work? If it's not working for them, those might be the people who are most likely to quit, right? To give up on the treatment or stop taking it or not follow instructions. So again, this could be where you end up with a sample. Your final sample is people who the treatment was working for, and the people who the treatment was not working for, they left the study early. So again, your sample's not really representative, or rather, it's not. It's kind of picking and choosing unintentionally instances where the treatment was working. And then you could probably imagine where that could also be the case for some sort of smoking treatment. Let's say it's some kind of therapy. Again, maybe people quit that where it especially isn't working for them. Okay, so with all that said, there's still actually more potential threats to validity um, in within subjects designs. And we'll cover this and then we'll get to how to actually fix these issues. The importance of mixing up your order. Another one is history related. This is where a historical or a cultural change occurs during the study in between your measurements. right? And you'll get some examples, don't worry. And then, of course, there's also maturation. Um, this is where development of the individual taking part in the study occurs between measurements. So going back to our earlier example, talking about testing an anti-anxiety drug on adolescents. Remember the study? This is 12-year-olds, takes place over a year, and we're measuring the parental reported anxiety symptoms. Our independent variable is the anxiety drug, either no drug, the new drug we actually think is going to do something, versus a placebo, which is again just a fake pill. Um, okay, so let's go through a couple scenarios. You find that contrary to your hypothesis, participants who receive the drug do not show long-term reductions in anxiety symptoms. So that would be this new drug condition not really doing better than either the no drug or the placebo condition. Something wrong here. Sorry. Okay. Sorry about that. Just had those hidden for now. So there was a problem. So your hypothesis was not supported. Receiving the drug did not show long-term reductions in anxiety. Um, why might that be? Well, let's say in one scenario, in August, a hurricane hit the community in which your participants live. Would this be maturation, history, or mortality? Well, this would be history, as this is where something is changing in the culture or um, the situation, not specifically to the individual. Well, it involves the individual, but it's not kind of a developmental process. That's maturation. Here it's kind of an outside factor. But this would be history, right? This is where, again, something outside the participant's control is going on that could affect your study. Or let me clarify, it's not just out of their control, because that could apply to maturation too, or even mortality, but something that is not developmental. So presumably, if a hurricane hit the community, this could really affect their anxiety levels. So that could be a confound here, right? Rather than maybe the new drug works, but it's offset or it's reduced um, by that hurricane. Okay, in contrast, let's say one of your data collectors noted that several of your participants appear to be going through puberty during the year of data collection. This would be maturation, because now it's a developmental change to the actual subjects. So they're probably anxious while going through puberty, and that could definitely affect your result. Again, now it's not clear: is it the new drug not working, or is it maybe being offset or being less effective due to anxiety associated with going through puberty? Right. So with all this in mind, it probably sounds like within subjects designs are kind of doomed and they don't really work. But that's actually not true, because there's a lot of ways that we can get around these issues, that we can fix these problems. So let's start off with carryover and testing effects. So this would be anything, again, that where a previous condition maybe makes you more or less responsive to the next condition, or practice or fatigue. set in? Well, one way we can address this issue, particularly with testing, is pre-training and practice sessions. All right. So let's go back to our example of cell phones and driving. Again, we're testing um, whether cell phones distract us while driving. Well, there's definitely the possibility that driving in the simulator is not really, it's kind of a new experience for participants, the driving simulator, and maybe it's not very similar to the way their actual car operates. So this could result certainly in practice effects if they just, you know, get to use, if they're using the simulator, they could get better and better in time at driving the car in the simulator because it's relatively novel to them. This again could disrupt our manipulation because let's say um, we test cell phones first and then we test them without cell phones in a within subjects design. Well, the obvious issue is that maybe it's not about cell phones, but maybe they're just getting better at using the driving simulator, or they're getting more comfortable with it, or how the simulated car handles, something along those lines. So a way we can offset this is to include practice trials. All this is it's pretty simple, is you're just going to have them do some trials, do some of the well, actually not part of the experiment, but do some trials that don't actually count towards towards your dependent variable. The goal here is that their practice effects should be over with by the time they actually start the experiment. So again, going back to the driving example, the driving simulator, the assumption would be there that there's only so much of a difference that practice can make. So maybe the first, say, 5 minutes that they're in the driving simulator, you get a big practice fix, and while they're getting used to it, they get much better over time. Beyond that initial 5 minutes, more and more practice is going to make less and less of a difference, or maybe no difference whatsoever. That's kind of the assumption, and it's not always true, and why maybe a practice effect is not, or rather, a practice session is not useful. But there are a lot of situations where we might expect practice effects to be substantial. So therefore, we include some practice trials to see how to get people used to doing the experiment, and therefore, additional practice beyond that is going to make little to no difference. Right? Another example would be something, a lot of perception experiments. So, for example, there's something known as lexical decision. This is where you get a word on screen or a non-word, and you have to classify it as a word or not as quickly as you can. Most people come into the lab and they've never done this before, and you get a pretty substantial practice effect. Therefore, you end up doing a bunch of practice trials before you move on to the actual experiment. And again, the assumption here is that practice becomes less and less useful. So after they practice for, say, 5 minutes or whatever the number is, additional practice beyond that is not really going to help. And therefore, practice effects between the actual conditions where you actually measure the dependent variable are going to be pretty much irrelevant. Okay. Now, in terms of some of the other issues, like, say, fatigue, habituation, dishabituation, or sensitization, um, these can be addressed using rest periods between treatments. Okay. So if someone's getting really tired between, it's a longer experiment, they're getting tired or bored, giving them a break in between treatments can obviously help them recover to some degree. And how long that period might be is all dependent on your study. Sometimes you give them 5 minutes, sometimes you give them a day. Again, it just depends on your study. Right? And similar to that, we might have spaced out conditions where we have people do the conditions obviously over days or over weeks or whatever it might be, again, depending on the research question. So if you're doing an experiment that's, you're pretty worried about, say, learning, contrast, it might be useful to have spaced out conditions. To give you an example, let's say you're doing a memory experiment and you're really worried about carryover effects or learning effects where information from the previous condition could carry over and affect the current condition or the next condition. Well, a relatively straightforward way around that is just to space out the conditions and maybe test them on different days, but still keep it as a within subjects design. And you can imagine how these things, rest periods or spaced out conditions, could be useful for something like a biological process where we give people some time, or say their rods and cones, to return to a normal level. Okay. So that's all. Those are all good ways in which you can address, um, or at least kind of a good starting point to address carryover and testing effects. But next, let's talk about possibly an even better way, which is, of course, counterbalancing.